They can also kind of completely resculpt circuits and change things potentially even permanently, after a woman gets pregnant or after you go through puberty or what have you. So multiple time scales with which these things affect neurons, including physically like rewiring them.
Exactly, exactly. And that's why they are so interesting for us as well, because they really they have the potential to basically create these plasticity windows even in the adult brain. And this is what we see in our prior work in during pregnancy, for instance. During pregnancy, you have these crazy increases in the levels of progesterone and estradiol. And what we think is happening is that during these massive increases, they again open up a window of plasticity during which parenting circuits are remodeled, for instance, in anticipation of the animal needing to perform really robust parental behavior. So that's the adult brain, which is commonly thought to be, rather, static and less plastic as the developing brain. But the changes that we see there are really comparable to what's happening in the developing brain. Yeah.
And so if we step back for a moment, we can think about things like sex hormones that fluctuate across the estrous cycle and development, right? They go up, they go down. We can also think about hunger and satiety hormones coming from the gut. When you're more hungry or more satiated, these hormones start to change. So there's this whole soup of proteins and molecules and things, all of these different hormones, they're going up, they're going down day and night, week by week. And the sort of the integrated average of all these things, the sort of profile of that goo at any point is going to dictate what neurons are likely to do or not do. And so this is how we can maybe start to think about what sets the state of the animal, how likely it is to engage in certain behaviors is sort of like the sum total of all of these hormones and other factors that regulate how excitable or that regulate what the neurons are gonna do or not.
Exactly. And that's even, that's already super complex and high dimensional. But then those are even just the sort of the wireless connections, but then you have the wired connectivity between the brain and the rest of the body as well. The vagus nerve, which, I guess informs the brain of the state of the body at any given point in time. So you have this really, dense interaction between the brain and the rest of the body, using wireless and wired connections.
Mm-hmm. Yeah, I think that's a good analogy. So wired versus wireless connections. So neurons are literally hooked up to each other like wires. But what you're saying is basically a wireless connection would be if you have a hormone that like estradiole's high, maybe progesterone's low, so the ratio is really high in one direction. Those hormones are diffusing into the brain and they can separately in two different parts of the brain far away from each other affect different circuits in parallel. So we can think of that as a wireless connection.
Exactly. I think that's how we're thinking about this. That's why these, sort of broadcast messages are so powerful, because they can, as you say, they can, sort of synchronize or coordinate very different circuits that are located in different parts of the brain, which are not even directly connected. So it's a very powerful layer of regulation there that we are not really understanding yet. But that's sort of my lab's goal, is to also understand the principles by which hormones coordinate circuit-wide activity to then, provide a different behavioral output.
Yeah. And so at a high level, it starts to become intuitive to think about what you mentioned earlier. So you can take a naive female mouse who's never been a parent, she's never been pregnant. You can put her in front of pups. And if she's hungry, she's not likely to take care of them like a mother mouse would. And you can start to think, okay, well, maybe her parental control network hasn't been turned on because she's never been pregnant, but she's also hungry.